Hi, this video is just going to kind of go through and review some basic algebra skills. First off, we're going to simplify each expression. So since there's no equal symbol, all we can do is put together like terms. So we're going to combine them. I see I have a 3x and I have a minus x. So when I put those two together, 3x and my minus x, remember that's really minus 1x. So 3x minus 1x is 2x. Then I'm going to look at my y's. I have a plus 5y and I have a plus 2y. So when I put those two together, plus 5 plus 2 is plus 7y. Since there's no equals, I can't do anything else. I'm stuck right there. That is simplified. Okay, let's look at the next one. Again, there's no equal sign, so we're just going to be combining our like terms again. I see I have a 7x plus 3x. 7x plus 3x, when I put those two together, is 10x. And then I have this minus 15 and this plus 4. Now when I put those together, I'm really subtracting, right? It's really kind of like a positive 4 minus 15, which is going to put me at a minus 11. Okay, so notice I did use the sign that was with the terms. So over here I had a 3x, a minus x, and I did subtract. I had a plus, and I did add. I had a positive 7x and a positive 3x, and I added. I had a negative 15 and a positive 4, and because of that negative 15, I subtracted. Sometimes we have to do the opposite when we're looking at problems like the next set where I am solving equations. So again, the difference between an expression and an equation is an equation, think equals, right? Equation, equate, I have an equal symbol, whereas up in these I didn't have one. When you have to move to the other side of an equal symbol, that's when you have to do the opposite of what it is. So up here I had a positive 3x, a minus 1x, so I subtracted. I had a positive and a positive, so I added. Here I have a positive 10, but I need to move it to the other side of the equals. So that's when we're going to do the opposite. Only when you're moving to the other side of the equals, not if there's not equals at all. Okay? When I do that, a lot of teachers will say these cancel out, but I don't like to use that verbiage because I like to remind myself, especially if it ends up on the side all by itself, that really it becomes a 0. Minus 10 plus 10 on a number line puts you at 0 on the number line, so it's really like a plus 0. So when I do that, I end up with my x comes down, and there's really a plus 0 here, but I don't have to write it. And then 24 minus 10 is 14. So x equals 14. Okay, so then let's look at the next one. On the next one, I have a over 3 equals negative 15. And a over 3 is really a divided by 3. So the opposite of dividing is multiplying. So I'm going to really multiply both sides by a divided by 3. I'm going to multiply by 3. And so that way these 3's, it's really like 3 over 3, which is 1. So that's why they cancel out. It really becomes a 1 times that a, which leaves me with a equals, and then on this side, negative 15 times 3 is negative, oops, I almost forgot my negative, negative 45. Don't forget your negative there. Negative times a positive is a negative. Okay, and that's a 4. It's a weird looking 4. 45. Okay, all right, and then the next one on this row is almost the same as the last one, except instead of a divided by 3, I have 3a, so that's really 3 times a, and the opposite of multiplication is division, so this time we are going to divide both sides by 3. And so just like over here, I ended up with 3 over 3, which canceled to a 1. I have 3 over 3, which also divides to a 1. So 1 times a is just 1a, which we just write as a, equals negative 15 divided by 3 is a negative 5. Okay. On the next one, I have 4x plus 5 equals 37. So again, I need to move this 5 because I have to get the term with the x all by itself. I have to move the 5 to the other side. So I'm going to subtract 5 on both sides. You can't just do it to one. Remember, I like to remind myself that plus 5 minus 5 really becomes a plus 0. So then my 4x is going to move down. And there's really a plus 0 here. I just don't have to write it. And then 37 divided by 5. Let me move my paper up. 37 divided by 5 is 32. So 4x equals 32. It's really 4 multiplied to x. So I'm going to do the opposite and divide. So 4 over 4 is 1. 4 divided by 4 is 1. So I end up with 1x equals 32 divided by 4 is 8. Okay, just 3 more for this activity. All right, so the next one, I need to get the 3x, the term with the x in it by itself. So I need to move this 2 away. So I'm going to do the opposite since I'm going to go to the other side of the equals. And remember, instead of saying cancels out, I like to say this turns to a plus 0. So I end up with 3x plus 0, but I don't have to write that, equals 27. Then I'm going to divide by 3 because I have 3 times x, or 3 multiplied to the x, and the opposite of multiplying is dividing. 3 divided by 3 is 1, so I have 1x equals 27 divided by 3 is 9. Okay, 2 more. All right, when I look at the next one, 3x minus 6 plus 4x plus 18 equals 26. So the first thing I'm going to do is I'm going to ignore the right-hand side. I'm going to ignore this plus 26. I'm going to pretend it's not there. And I'm going to deal with this side just like I did with those very first 2 top examples where there was no equals. And I just combined my like terms. So I need to simplify the left-hand side before I can move to the other side. I'm going to look and see that I have a 3x, and then I have a 4x, and they're both positive, and since they're both on the same side of the equals, I am just combining like terms. So it's a positive 3 and a positive 4, plus and plus, so we add together 7x, and then I have my minus 6 and my plus 18, so it's a minus, so I am going to subtract since I'm staying on the left side of the equals. And a positive 18 minus 6 is a positive 12. And then I have left over here my equals 26. So now that I'm going to start moving from one side of the equals to the other, now is when I'm going to do my opposite. So a plus 12, I'm going to subtract it. So that becomes a plus 0. Plus 12 minus 12 is a plus 0. 7x plus 0 equals 14. 26 minus 12 is 14. 7 multiplied to x equals 14. The opposite of multiplication is division. I'm going to run out of room on my paper. 7 divided by 7 is 1, so 1x, which is just x, equals 14 divided by 7, which is 2. So x equals 2. Okay, last one. On the last one, I can see I have 3 times x minus 7, and it needs to be multiplied to everything inside these parentheses. So I need to make sure that I distribute 3 times x and 3 times the minus 7. 3 times x is 3x. 3 times a minus 7 is a minus 21, and that equals this negative 15. So I don't have any like terms on either side like I did in this problem. Nothing to put together. I know sometimes I look at this problem and I go, do I have any like terms? And I'm tempted to call these 2 like terms, but they need to be on the same side of the equals for me to combine them as like terms. So I don't think of these really as like terms in the same expression because it's 2 sides. Which means I need to do the opposite to move to the other side. So I'm going to add the 21. Remember, this becomes in plus 0. Minus 21 plus 21 is a plus 0. We break even. 3x plus 0, but I don't have to write that, equals a negative 15 plus 21 becomes a positive 6. 3 multiplied to x equals 6. The opposite of multiplication is division. 3 divided by 3 is 1, so I have 1x equals 6 divided by 3 is 2. So we got 2 again for this answer. Okay, so there is just a little quick review on some algebra skills on combining like terms, simplifying expressions, and then solving for a variable. Okay, hopefully that helps.